Okay, today we're going to change topic to the philosophy of science, and in particular consider what makes something a science, what makes something good science versus bad science. And I've chosen Karl Popper as a philosopher, partly because he's been an influence on me, but also because a number of scientists, Nobel Prize winners like John Eccles, Peter Medawar, have explicitly said Popper was invaluable to them in helping them do their science. And others like Richard Feynman, the bongo-playing Nobel Prize-winning physicist, whenever he talked about science, he was talking about the philosophy of Karl Popper. And that was important to Feynman as well, to how he did his science. So the sort of question we're interested in is something like, what is science? Or what's the difference between science and pseudo-science? Or the difference between good science and bad science? Well, the question is, how could you improve your or someone else's work to make it better science? Or whether creation science, Scientology, astrology, traditional Chinese medicine, are they sciences? Or anything else you might wish to put on that list, and why does it matter? Well, really, the question Popper was interested in was not just a labelling game. He wasn't interested in saying, we'll label this science and non-science. He was interested in a substantial question, and that is, how does knowledge grow? So how do we learn more and more? And that's important for things like, I don't know, traditional Chinese medicine or alternative therapy or chiropractic or something like that. If you're going to take something for your hay fever, do you want to take something that was developed in a tradition which we believe would lead to the development of knowledge, or to a tradition that lacked those properties? Well, Popper's answer to the question, how does knowledge grow, sounds simple. So at first we can say very generally, knowledge only grows by critical discussion. Now, I don't know if that just sounds like a platitude to you, something obvious. But when you look at knowledge traditions, that isn't actually how most traditions in the world historically have operated. Historically, what happened was the aim of a tradition was to transmit the master's words unchanged, to preserve them. And indeed, if you challenged them, that was a very bad thing. So if you wanted to introduce a new doctrine, you would have to say something like, but this is what the master originally meant. Or this was the secret doctrine, he only taught some people. Or this is the proper interpretation. The critical tradition, something else happens. And Popper conjectures that this happened only once in human history. Whether that conjecture is true or not doesn't really matter. But anyway, his conjecture was that it happened around about 500 BC with the Greek Thales, the Greek philosopher Thales, because he did something that strikes most masters as just something you don't do, which is, he said, I have a conjecture about the structure of the world there was in that case. Now, maybe it's right, and maybe it's wrong. And maybe you, my student, maybe you can criticize it and make it better. And that's the critical tradition. When you pass on to your students not just some doctrines, a body of theory, but a higher order tradition of, and criticize my ideas to improve them, then that's the critical tradition. And that's a very hard thing for a person of authority to do, to say to their students, please criticize me, I'll take your criticism sincerely, and let's see if you can do better than what I did. But according to Popper, it's only when you've got that you have the beginnings of science. Science is just a little bit more than that, but you need that. You need the critical tradition. And that's how all knowledge grows, not just scientific knowledge, but any knowledge like philosophy, other bodies of knowledge that aren't science. They grow by criticism, by conjecture being put forward, being criticised, and thereby being improved. Now, I put some pictures of martial arts up here because I'm a martial artist, and for decades I followed the traditional method in teaching martial arts. In other words, I said, because I belong to a style, or a set of styles at different times, where I said, now you do this because the master says so. Of course, you come up with some reason, but ultimately you do it because that is the way it's always been done. And in fact, the earlier back in time you can say that this goes, well, the better it is. That's the true sign of something great, is it went back in time a long time to the original master, all the way back then. But I found the critical tradition, which in martial arts is something like mixed martial arts around today, my students got better a lot quicker. I would say, here's a problem, someone pins you on the ground, I want you to get up, I have some solutions, look, this is how I do it, but maybe you can find something better. I don't mind if you don't do it my way. Here's a way that I find really effective. Try it, get to know it, improve it if you want. So the aim isn't to make my students carbon copies of me, it's to make them effective. It's to take part in a critical tradition, and then you get an explosion of learning and knowledge and new solutions happening. So although when Popper says knowledge only grows by critical discussion, sounds simple, actually I don't think it happens that often. And so we're part of a rare tradition and being part of a scientific tradition, and then we see the benefits of that in terms of the explosion of knowledge that we've witnessed. Right, now what we need to do is to spell out just in a little bit more detail how do we turn a critical tradition, which is something very general, into something that's specifically science. So I'm going to go through some examples, and we'll discuss them. So consider this quote from Freud. He says, if an otherwise highly intelligent patient rejects a suggestion, in other words, an interpretation for their symptoms and their problems, Freudian interpretation, psychoanalytic interpretation, if he rejects it on not too intelligent grounds, then his imperfect logic is evidence for the existence of a strong motive for his rejection. That's a little bit complicated. It was just the closest quote I could get to Freud for the point I want to make. So I'll spell it out with an example. Let's say you're an analyst. The person who come to see you is a paranoid male. Now, Freud says that paranoia is actually unconscious homoeroticism. So, when he tells you about being hit by a big stick, you say, of course, you have unconscious homosexual tendencies. The patient, so two outcomes. The patient accepts the interpretation, says, yes, that does make sense to me now. So you conclude your interpretation was correct. Or the patient strongly rejects it and says, now come on now, I'm perfectly straight, I can't accept that for a minute. Saying, he protests too much. My interpretation hit pretty close to the mark, it must be right. So, what do you think of this as a strategy for establishing the correctness of dream interpretations? Just tell the person next to you, I'll just give you 30 seconds to say, what do you think of this as a strategy? And if you think there's something wrong with it, what was wrong with it? Just introduce yourself to the person next to you and tell them what you think. Okay, so I think the question you could ask is, to, say, you as the analyst, how would you know if you were wrong? How do you get feedback from nature, from the person, from the clinical situation, that lets you know when you got it wrong? And you can't by this strategy, right? Because whatever happens, you conclude that you're right. So Popper concludes it's yes.
With Freud's original quote on that, isn't there space if the patient rejects the suggestion as intelligently as you would expect?
Yes.
The analyst could make something.
Yes. On Freud's quote, the situation doesn't quite reduce to the two alternatives that I've put there. However, one of Popper's criticisms of Freud was that he didn't set up situations that would let him know that he was wrong. Although, in actual fact, there was a lot that Freud said that could be tested. It's just a pity that he didn't. Perhaps Freud, I think, had a lot of really interesting ideas, a lot of ideas that were right, but a lot of nonsense as well. And what he didn't have was the feedback mechanism that sorted out the wheat from the chaff. So, I'm now going to take an example. This is a real example, so I'm taking an example from psychology, current theory. And let's look at really the same sort of issue. So a question you might ask is about why do people like certain things and not others? And let's just say we're talking about food. You see individual differences in preference for food, and Mexicans tend to like, and Koreans like spicy food, and so on. But other people don't like spicy food because they weren't brought up on it. But there are individual differences in tasting preferences, even within a culture. So now, one theory, and you may know about the mere exposure effect, says, well, there's two factors here. One factor is the mere repeated exposure to something makes you like it. Familiarity will tend to make you like it. And maybe an evolutionary reason for this, certainly when it comes to food, is if your parents give you things so you get used to the taste, well, that's something that's safe. So if something tastes familiar, it's safe, it's okay to like it, that's something you can eat. But you probably had the experience of listening to a song. The first time you thought, yeah, whatever. The second time you thought, okay, yeah. And the third time you quite liked it, and the fourth time you really liked it, and so on. So just by exposure to it, you learn to like it. But you can hear it too often, right? You can get bored with it. And so there's also a boredom factor, whereas when you become familiar to things, you get bored, and maybe that's because, for evolutionary reasons, we need to be a little bit curious. If we were never curious and never wanted some novelty, we'd never really learn much. So we have two factors that act in opposition to each other. There's a mere exposure effect, familiarity factor that makes you like things, and there's a boredom process that makes you bored with things as you become familiar with them. So we run an experiment and we get our chemists to create a completely new taste, not quite any that our subjects have had before, and we get them to taste it and write down how much they like it, and we do that at 3 time points. And we find for this taste X that first time point the liking is here, then it goes up the second time point, and then it goes up again. And we say, yes, we have an explanation for this. Yeah, that's completely consistent with the theory. That's the first factor operating. As you become familiar with things, you like them more. That's just what we were saying in our theory, you say. So the results confirm the theory. Then our chemists come up with a different taste, taste Y, and we take liking, and we find now that the liking goes down at each of the time points. And you say, yes, that's the second factor. Yeah, that's the boredom factor operating. Of course, sometimes when you get exposed to something a lot, you get bored with it and you like it less. So the results confirm our theory, our two-factor theory. And then a chemist come up with another taste, and the liking first increases and then goes down, just like the example I was talking about with listening to the song, and you say, well, yes, of course. That's both factors operating. First of all, it was the first factor making you like it, but then you got bored with it and it went down. So that confirms our theory as well. And then finally, for the next taste, it first goes down and then it goes up. And you said, well, yes, it can do that sometimes. You see, sometimes the second factor kicks in first. And then the first factor operates. So you're getting a bit bored with it, but as the familiarity grows, you learn that it's safe, and you think, no, actually, I do like this, after all. So, yes, the results confirm the theory. So increasing people's exposure to a new thing can increase liking because of the first factor, decrease it because of the second factor, increase it and decrease it because of both factors, or decrease it and increase it because of both factors. So you conclude the theory is a good one because it explains all these outcomes. So, turn around to the person next to you and just discuss that conclusion. Do you think this is a good theory? And I haven't chosen the Mickey Mouse theory. This is an actual theory that's out there. Okay, so the problem here is it's really the problem the first time around, but I try to come up with an example that's a bit more subtle, actually real in the sense you'll often come across this sort of example. When you read papers in psychology, look out for this. There's no way the theory can be wrong. So there's no way, in other words, that the evidence could show the theory is wrong. You can never get feedback telling you that the theory is wrong. Yes?
What happens if it stayed the same the whole time? Wouldn't that prove the theory is wrong every time you tried it?
Well, a good point. I didn't have all the combinations there. That would show that the first factor and the second factor exactly cancelled each other out. We can explain that too. So for Popper, when you make theories fit data, so I can explain that, I can explain that, explain that, explain that, explain that, explain that, that comes too cheaply. And for Popper, that was the problem with Freudian psychoanalysis, also with Marxism as it became. Whatever happened, people say, yeah, I can explain that. But the explanation always came after the fact. After the data came in, he said, yeah, I can explain that. Now, that doesn't mean that the theory is false, and it doesn't mean that the theory is meaningless. And Popper would say the same about psychoanalysis. He didn't think psychoanalysis, he thought that it said many true things and many important things. But you're not actually doing science yet if no matter what the empirical observations are, you could never show that the theory was wrong. There must be some observation that contradicts the theory for you to be doing science. Okay. That's the distinction between science and non-science for Popper. So this isn't science yet. So if you wanted to sum up Popper in one word, it would be falsifiability. Science is having falsifiable theories where you have a community of people actually trying to falsify them. So to take the theory that we just dealt with, that could be the perfectly good basis for some science, as long as you could come up with some reasons for predicting which of those results are you going to have. If you can predict which of those patterns in advance because of something else, well, now you're in the business of science, because that could be falsified. The prediction could be wrong. So here's some statements that really every experimental psychologist feels in their bones. They haven't all read Popper, they don't all know that it came from Popper, but you can see this in how they think and how they operate. The content of the theory increases with its degree of falsifiability. The more falsifiable the theory, the more the theory actually says something that has some content, scientific content or empirical content. The more a statement or a theory, the more a theory forbids, the more it says about the world. You're actually saying something when you're forbidding a lot of observations from happening. A theory that forbids many outcomes is easy to falsify. It asserts a lot about the world. A theory that allows everything explains nothing. So let me illustrate those claims, which are all really sort of saying the same thing in different ways. Imagine I have two theories, theory 1 and theory 2, which are about earthquakes. And I'm going to predict when the next earthquake will happen in Tokyo. So let's say we have along the bottom axis here is time, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and so on. And here on the vertical axis is intensity of the earthquake. So now what this first theory is saying is almost any intensity can happen at almost any time. The only things it rules out are these green bits in the corner. But this theory here, theory 2, says it's going to be on Tuesday between 12 o'clock and 4 o'clock. There's going to be an earthquake of this intensity. And everything else is ruled out. There's not going to be earthquakes any other time. Now, let's say what happens is an earthquake does happen at that time and of that intensity. Now, neither theory is falsified in the sense that outcome is consistent with both theories. Right? But which theory do you prefer? Theory 1 or theory 2? Theory 2. Someone said theory 2. Yes, I prefer theory 2 as well. So theory 2 rules out all of these things. So if an earthquake had happened at this time and this intensity over here, it would have falsified the theory. It forbids a lot. Whereas theory 1 just says, yeah, any intensity at any time, more or less. So theory 1, you could say, allows almost everything and explains almost nothing. That's Popper's intuition here. You're going to prefer the theory that rules out a lot. Then when the earthquake does happen then, you say, actually, I think this theory is getting at something. I think this theory is explaining things. So what we're looking for in our theories are theories that are highly falsifiable. And highly falsifiable means that there's a whole list of things that would show that theory wrong. And if you're a good scientist, what you do is you say, well, the theory would be wrong under these conditions. Let me try and set up these conditions and see what happens. So you're actually trying to falsify the theory. So Freud made some falsifiable claims, but he didn't go about trying to falsify them. So it wasn't quite science yet. What we need is a community of people trying to falsify claims which are falsifiable. So it doesn't matter, I mean, a particular scientist might propose a theory and not vigorously try to falsify it. As long as someone else in the community is, so as a community we're doing this, then we're in business. So that is the essence of Popper's theory. Okay, now let's consider a claim that in human beings the hippocampus is required for spatial navigation. Now, you find Sam, who due to a recent unusual viral illness has had destruction of all his hippocampus and just his hippocampus. You give him some spatial navigation tests and find that he's very bad. Now, tell the person next to you, do you think that you have, by this observation, established that the theory is true? Just say yes or no to the person next to you. Have we established that the theory is true yet? Well, it's consistent with the theory, right? But you wouldn't want to say that we've shown the theory true yet. Sam is just one guy. He happened to have bad navigation and he didn't have a hippocampus, but it hasn't proven the theory right. We haven't established the theory yet. So then you find a bunch of patients in the neurosurgery ward of a local hospital. They'd had some car accidents, and they were freakish car accidents in that they managed, due to head injury and an unusual pattern of reverberations going on in the brain, to destroy the hippocampus and just the hippocampus. And you think, great. You give them some spatial navigation tests, and you find the spatial navigation is very bad compared to the normal population. So, have we established the theory is true yet? Yes.
But the theory says that hippocampus is required for spatial navigation, not that spatial navigation is impaired when it's destroyed. So, to sort of get closer to confirming it, when you have to find someone who has bad spatial navigation before when the hippocampus is impaired.
Yes, it would be nice to have evidence the other way around, if that's what you mean. Of course, it's saying that hippocampus is required for spatial navigation, but other things might be required as well. So that wouldn't quite falsify the theory. If you found someone with good hippocampus and bad navigation, it might be the hippocampus is required and some other things are required. But it would help. It would help make the case. But we wouldn't, so that wouldn't establish the theory. Yes? You can't prove it to be true.
You don't prove it. You never prove it to be completely true.
Yes.
You always everything like you can do it.
Yes.
You can just strengthen it like this would strengthen the theory.
Wouldn't prove it's true. Yes, that's right. So we haven't established the theory yet. And why haven't we established theories? You're right. We might begin to think there's something to the theory. But then you find your 21st teenage driver with complete destruction of the hippocampus has excellent spatial navigation. Now what can you conclude? Yes. Now we can conclude the theory is false. So, just like you were saying, no amount of evidence ever shows a general theory is true. Scientific theories are never conclusively established. But evidence can show a theory is false. So there's an asymmetry here when we're talking about general theories. So we should be happy, Popper concludes, when our theories are falsified. We learn more from negative evidence than positive evidence. This point was really taken to heart by John Eccles, who's a Nobel Prize winner. But just because he was a bright guy and worked hard and eventually won the Nobel Prize, doesn't mean that all the theories he worked on were true. Just because he's an authority, we shouldn't expect him, therefore, to propound only true theories. In fact, for 10 years he championed the theory that transmission between neurons was electrical rather than chemicals moving in a synapse. We now know that it's neurotransmitters moving in a synapse. He was wrong. So, when he found out he was wrong, he was very depressed. But then he met Popper. And he said, scientists have often been loath to admit the falsification of the hypothesis they've published. Whereas according to Popper, falsification is the anticipated fate of all hypotheses, and we should even rejoice in the falsification of the hypothesis we have cherished as our brainchild. When you take on this attitude, you are thereby relieved from fears and remorse, and science becomes an exhilarating adventure. And maybe in a way this is similar to the Buddhist message I was talking about last time, that we shouldn't be attached to views. When we propose a theory, think of a theory as something that has its own life. This is what Popper says. It has its own reality apart from yourself. And what we're interested in knowing is this theory true or false? And when we find out that it's false in some way and we can do better, well, we've learned something. And that is a great thing. Now, these sorts of conclusions, I think, particularly struck Popper because he was around at a very interesting time in terms of science. He was developing these ideas probably around the 1920s onwards. And up until about 1900, people thought they had wrapped up science really pretty well. Newtonian physics had been confirmed in many different places, in many different ways, in a stunning way. No one doubted Newtonian physics. Then, 1905, with the special theory of relativity, 1915, the general theory of relativity. Over that period, quantum theory being developed. For both point of view of relativity and quantum physics, we can conclude Newtonian physics is wrong. So a theory that had been accepted for hundreds of years, had confirming evidence for hundreds of years, that seemed utterly infallible and beyond doubt, was shown to be wrong. So this was a very influential experience for Popper. It doesn't matter how much evidence you get for a theory, there may yet be a better theory. And we should be looking for a better theory. And he was very impressed by Einstein, who said, look, I've got this theory, it does explain some problems with Newton's theory of gravity, but look, if you go and do these observations, and it doesn't come out this way, then my theory's wrong. So he said in advance the conditions under which he would drop his theory. Turned out the theory was confirmed. And that impressed Popper. And that struck him as the opposite. He was briefly a Marxist, briefly did some work with some psychoanalysts, and there the attitude was completely different. They would never say the conditions under which they'll drop the theory. They would say, my theory's right. And when anything happened, they would say, yeah, I can explain that, it's because of this. So that was the difference for Popper between science and non-science, and also illustrates why he thought it was important. It would be terribly important. This is a matter of practical life and death importance, and clinical importance, in terms of how we're developing our knowledge. Now, one thing I want to bring up is Popper's attitude to evolution, because one of the great accomplishments of science is the theory of evolution, Darwin's theory of evolution. And you might know there's been lots of debates about it, especially in America, with creationists and intelligent design people saying evolution is wrong, or at least it's just a theory amongst another theory like creation science or intelligent design. So maybe you'll be surprised to hear that Popper said Darwin's theory of evolution in itself is not science. That was his argument. So I just want to go through his position and my response to it. So if we were to boil down Darwin's theory of evolution, it would be something like this. There are some variations which are copied to the next generation, others are not, depending on circumstances. Some variations, some mutations, well, Darwin didn't know about mutations, but that became added. Some variations happen to fit the environment and others don't and get weeded out. And what you end up with is a particular course of history happening. Evolution is a particular sort of history. Now, according to Popper, you cannot predict the course of history, evolutionary or otherwise. You cannot predict human history. There's no theory that says how societies must evolve or what must happen in history. And the same for evolution. So the theory is not falsifiable. You can't make predictions in advance about what will evolve. So it's not a scientific theory per se. Now, he, under the influence of some other philosophers like Thomas Kuhn and Imre Lakatos, Popper developed a notion of what he called a metaphysical research program, by which he meant things that are not science we can call metaphysics. What he means by metaphysics is just not science, so not falsifiable, that's metaphysics. But for him, metaphysics doesn't mean meaningless, it doesn't mean nonsense, it doesn't mean false. In fact, metaphysics can be extremely useful, extremely valuable. His own theory of falsifiability is metaphysics, but in Popper's mind, very valuable, very useful, and very meaningful. So when we're calling something not science, it doesn't mean that it's a load of rubbish. It just means it's not science yet, and we're not making use of a particular way in which our knowledge can grow, namely feedback from nature about when we get things wrong. Now, science has falsifiable claims in it, but it also has metaphysical claims that guide the falsifiable claims. And evolution is like that. He said evolution is a metaphysical research program that's been invaluable to science in generating specific research hypotheses. But it just isn't a scientific claim in itself. So he loved evolution and liked to write about evolution and contribute to debates on evolution, and he thought evolution was an invaluable part of the scientific process. It just wasn't a scientific theory in itself because it wasn't falsifiable. Now, I think Popper is, yes?
But surely you can prove evolution was false, the evolution that has happened was false. Say if you found a fossil that was out of place in the stratigraphy of the Earth.
Yes, I think you're coming to the next slide now. Good point. I just say I think Popper's largely right in the sense, pick up any journal in evolution, pick up any article and ask yourself, would these authors have given up the theory of evolution for any of the observations they might have made in that journal, in that particular article? Yeah, pick up an article on evolutionary psychology, they do some sort of experiment. Would they have given up the theory of evolution for a given possible set of outcomes of the experiment? No, they wouldn't. They wouldn't have given up the theory. No matter how the experiment turned up, they wouldn't have given up the theory of evolution. So most of the time, evolution acts as a bit of background inspiration that isn't actually being tested by any particular study. So in a lot of ways, Popper is right, but I think he is actually, though, absolutely wrong in an absolute sense, just as you're saying. In fact, at the time of Darwin, Darwin had said, look, if you geologists are right about the age of the Earth, my theory must be wrong. It can't operate in those timescales. So Darwin then went about trying to find better estimates of the Earth's age. He wasn't trying to find estimates that were longer, he was trying to find better estimates. And when he found a better technique for estimating the age of the Earth, it was sufficiently long, he said, well, it's no longer obvious and my theory is wrong. The Earth is old enough, evolution could be right. So it is literally falsifiable. And as you're talking about, while any particular fossil, there's always a way out, it could have just got mixed up and so on. But overall, if the fossil record did not show the age-dependent changes that it does show as a general pattern, the theory would be a non-starter as well. And if there's no continuity of biochemistry and physiology amongst animals, I mean, let's say the biochemistry of humans was just completely different to the biochemistry of chimpanzees, which is just completely different and utterly alien to the biochemistry of dogs, we would say, well, you really think there's a continuity, a family resemblance between all these things? The theory would be a non-starter. As it is, there's staggering biochemical, physiological, and anatomical continuity between living things that makes a family resemblance pattern. So I think Darwin's theory is literally falsifiable, but just in these particular very broad ways, and in most of the details, it isn't acting as a falsifiable theory. But you can contrast that to the theory God created life according to his wishes. Now that theory can produce any pattern in the fossil record, any pattern of physiology and anatomy and genetics, and is compatible with any age of the Earth. So that is a completely non-falsifiable theory, and by contrast to creationism or intelligent design, evolution is indeed falsifiable. So I think Popper got that a bit wrong, is what I want to say. I think theory of evolution is falsifiable and is therefore science. So now, one interesting thing about the critical tradition that we've been talking about, and science is almost the apex of that, is it's unique to humans. So although you can say other animals have language in some way, only humans can use language in a way in which we describe a state of affairs, and then we can treat that description as an entity in itself which we can criticize and argue about. And so whatever conceptual framework we find ourselves in, we can always describe it, analyze it, and break free of it. And that is indeed how humans become free and flourish, is by critical discussion of the frameworks in which we operate. Because often you see, like in old society where there's intense sexism or slavery, the issues may not even be raised, they're just taken for granted. It's only by raising the issues, describing them, relating them to general principles of fairness, criticizing them and saying how it could be better, that we find freedom. But our ability to do this is always under attack from people who want power, from politicians, from business people, from religious leaders who tell us not to criticize, not to speak out. You do not have the freedoms to do this, and we constantly have to fight back in all societies and all times to establish what is uniquely human. And that brings me to actually what made Popper originally famous in the West, which was a political philosophy. I just mention it because his political philosophy is really the same as his philosophy of science. He wrote the book The Open Society and Its Enemies, I think around about 1945. He regarded it as his war effort, as his effort against authoritarianism. And the basic idea is this, that societies that promote the critical tradition as extensively as possible, we can roughly say they're open societies. So science, the essence of science is the open society. But the open society taken more broadly and politically, that's the essence of democracy. That's what democracy is. Voting isn't really definitional democracy. Democracy, on Popper's perspective, is the open society. So we can make a number of analogies with science and politics. Popper argued that posing the problem for a political system to solve as how to choose the best leader is ill-conceived. And that was what political philosophy took itself to be doing. How do we know who's going to be the best leader? Well, we can't know who's going to be the best leader. But just as we cannot know whether we have a true scientific theory, and there is no method for generating a good theory or a true theory. So Popper, who was the professor of scientific method at London School of Economics, said he might be the only professor of a non-existent discipline because he didn't think there was a scientific method in the sense of a method that generated... There's no method by which you come up with good or true scientific theories. All you can do is come up with conjectures. What science is not about generating the true theory in the first place, it's about testing it after you've got it. The original statement of theory is just an imaginative guess. It's just a speculation. It's just something you throw out there. And political leaders are the same. You don't know they're going to be good or not. You just got to throw one out there. But then what you need is a way of weeding them out, getting rid of the bad ones. And you see, that's what democracy does, is you get rid of the bad leaders without bloodshed. So if it does go bad, you can get rid of them without people being killed. And in science, if there is a bad theory put forward, we'll eventually find it out because we get feedback from nature about it being wrong, and we can get rid of it because it's falsifiable. And we are seeking to falsify it. So the essence of both science and democracy is the open society. And it was interesting, I read a book on the history of science. And developments in science have always gone with the most freest societies. The ancient Greeks, when they developed democracy, there was a flourishing, the initial flourishing of science. that grew to a spectacular degree. When democracy was wiped out in Greece, science stagnated. 1,500 years of darkness. And then when the embers were ignited again, both of liberal thought, freedom of speech, the freedom to say and to criticize, science flourishes again. So we could lose it all again. It happened for 1,500 years. Just because we have science now, there is no inevitability to history that will keep it. Okay, so to summarize, here's some quotes from Popper. Bold ideas, unjustified anticipations, and speculative thought are our only means for interpreting nature. So that's what I was saying about there is no method by which we induce or come to the right scientific conclusions. Treat all theories as guesses, as conjectures. But then having the conjecture, we need to test it. And those among us who are unwilling to expose their ideas to the hazard of refutation do not take part in the game of science. Now here's an interesting question I find genuinely useful. It's very simple, but really useful, and will help you to be a better scientist. And you could ask this about your project. You just say to yourself, how would you know if you were wrong? How would you know if your favourite theory was wrong? Just ask yourself that. And you'll be surprised how many tricks your mind plays on yourself. And you say, oh no, if that happened, I'd still keep my theory, because we're too attached to the theory. But if you can work out ways in which you're genuinely wrong, you'll be doing better science, and you'll be more respected for it by scientists, and knowledge will grow faster as well. Okay, thanks very much.